Okay, this video is about vector and scalar quantities and how they apply to our physics course. So, scalar, if a quantity is scalar, it is only size, it only has a magnitude. And if it's a vector, it has a magnitude and a direction. So what does that mean? So let's take, for example, difference between what we'll call distance and what we'll call displacement. Okay, so when I'm talking about distance, I could say I could say it's 5 kilometers from here to downtown. Okay? So if I told you it was 5 kilometers from here to downtown, I could be anywhere. So if downtown is here and I'm 5 kilometers away, I could be over here. That would be 5 kilometers away. I could be over here. That could be 5 kilometers away. I could be over here. That would also be 5 kilometers away. Right? So distance, because it's a scalar, it only has a magnitude, it only has an amount. So if it's 5 kilometers. So if it's 5 kilometers, I don't know whether it's 5 kilometers west, 5 kilometers north, 5 kilometers south. I just know that you're 5 kilometers away. Whereas displacement has both both amount and direction. So displacement is a vector quantity. So if I said if this is downtown, and I say we're 5 kilometers west of downtown, so I would know that I was indeed here. So I would be 5 kilometers to the west of downtown. Okay? So there's going to be a lot of different quantities we use that are both vector and scalar in this course. Here's a brief list. I won't name all of them, but I'll scroll through them all so you can see them. Like we mentioned before, displacement is a vector quantity. Distance is not. Speed is how we talk about how fast an object is going. Velocity is how we talk about how quickly an object is going and its direction. Acceleration is also a vector quantity. I'm not going to read through all these. Just going to scroll through it so you can see them all. Okay, so what happens when I multiply two vector quantities? We'll get to adding and subtracting in a different video. So say that I have a vector quantity and I multiply it by a scalar quantity. So this is my vector. And the cool thing about vectors is their symbols always wear hats. Wear hats. So when you see this symbol on top of the number, you know that it's a vector. And this is my scalar. Okay, so when I multiply a vector and a scalar, I get a vector going in the same direction. So I get a vector times a scalar going in the same direction as the vector. Okay, so for example, if I multiply, let me